Today we are continuing in 2.5 with the rational zero test. And so let's look at my polynomial that I have down here that I want to factor completely. Now in the previous lecture we had an x cubed polynomial, and we were told that we had a zero somewhere. We were told, I think, that f of 2 was 0. And so then we proceeded to remember that if f of 2 was 0, then x minus 2 was the factor, and then we divided into the cubic polynomial. And so that's kind of what we want to do here, except for this time nobody's telling me anything about what is a zero. And so I need to come up with this on my own. Okay, now I could guess values all day long, and so the good news is that someone else has come up with what is called the rational zero test, or sometimes it's called the rational root, because we can call sometimes zeros roots. Okay, and so this is the rational zero test. If f is a polynomial with integer, they have to be integer, meaning whole number, positive or negative coefficients, then every rational zero of f has the form p over q, where p is a factor of the constant term and q is the factor of the leading coefficient. Okay, so what this basically is saying is that this is a way to choose what we could test, because we found out that by using the remainder theorem, basically, if I want something that doesn't have a remainder, then when I plug in the value here for x, then what I should get out is 0. So I'm looking for numbers that I put into f that give me out 0. And so there's a way that we can choose them without just guessing and checking. They always come in a certain form. So p, in this case, is the factors of the constant term. So p is 6. Now q is implied because it's up here in front of the leading coefficient, which is 1. So p, the possibilities are 1, 2, 3, and 6. Those are things that divide evenly into 6. That's what a factor is if I multiply 1 times 6, I get 6. If I multiply 2 times 3, I get 6. And that's, we're only using integers here, so we've exhausted our list for p. Now q are factors of the leading coefficient. Now 1 is really nice because basically q, the only thing 1 can be is 1. I don't have to write it once or more than once. So q is 1. So that means that factors, that basically the zeros will come in the form of p over q. So basically I'm going to have, and it's plus and minus each one of these. I'm just going to list all the combinations. So p are the numbers that could be in the numerator, and q are all the values that ends up in the denominator. Well, q is 1. So in every case, basically I just get 1 over 1, 2 over 1, 3 over 1, and 6 over 1. So basically I have 8 possibilities. Positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6. So what this rational zero test says, that if I have a rational, meaning that it's not like the square root of 3, which is irrational, then if this has rational zeros, then it's one of these essentially 8. Okay? So how do we check? Well, we found out that using the remainder theorem that if I get a factor that divides evenly into it, it should have a remainder of 0. So that means when I plug this value in for f, I should get out 0. Okay? So I've got Desmos here for us on my phone here. So I've got, this is a really nice feature of Desmos also, is you can define it as f, and then after that, basically if I use that same notation, so I'm just trying out, right? These are my possibles, and so I'm just going with the first one, which is positive 1. I put positive 1 in, and according to Desmos, I get out negative 8. That is not a 0. I'm moving on. So then I plug in negative 1 is my next one, and oh, look, that is 0. So I found out that f of negative 1 is equal to 0. Now, I really want 2 of them because I have a 4th degree polynomial. So every time I divide into it by a linear factor, right, this f of negative 1 tells me that x plus 1 is one of my factors, and so I can use that to divide into it. So this has a degree of 1, so if I have a degree 4 and I divide it by a degree 1, then what I'm going to get left is an x cubed. So what I really want is 2 possible zeros would make my life perfect, okay? All right, so that means I'm going to go on, and I'm just choosing them in order, and I find out, oh, look, how convenient for me that f of 2 is also 0. Okay, so I am going to now use this information. So if f of 2 is equal to 0, then that means that x minus 2 is the factor. So this doesn't matter which one I use first. So what I'm going to do is I'm going to take my fourth degree polynomial and divide it first by one of them, and then take that result and then divide it by another one. Okay, so let me start another. So this is my original polynomial. I had x to the fourth minus x cubed plus x squared minus 3x minus 6. And I'm just going to divide it by the first one that we found, which was x plus 1. Okay? All right, so what I have here, I'm just going to use my powers of division. X times x cubed will give me x to the fourth, so I multiply through both of these. I get x to the fourth plus x cubed. I need to change my signs because I'm subtracting, so I change my signs and subtract. This gives me minus 2x cubed. I bring down the next term. Okay, so now I need to multiply x by something that'll give me 2x cubed, which is negative 2x squared. And so now I have negative 2x cubed and then minus 2x squared. I'm subtracting, so I'm going to change my signs and add. This gives me 3x squared. These should always cancel. And then I'm going to bring down my minus 3x here as my next one. So I'm going to have a 3x up here, which gives me 3x squared plus 3x. I'm going to subtract, so I change my signs and add. This gives me minus 6x minus 6. And so then if I put minus 6 up here, then I should have negative 6x minus 6. If I do not get 0, and I'm quite certain that I've got the right factor, then I probably want to go back and look at my signs. Okay, so right now I can tell that my polynomial factors as x plus 1 times this result, x cubed minus 2x squared plus 3x minus 6. So I have it written like this. So this is f so far. Now I can still go a little farther. I still have an x cubed. Now this same 0 that I found over here, right? I found that f of 2 is equal to 0 will still apply to this new polynomial. And so I'm going to take this x cubed polynomial now, and I'm going to divide it by x minus 2. So just the x cubed goes under there. Okay. So now I'm dividing. So x times what is going to give me x cubed? That would just be plain x squared. That's x cubed minus 2x squared. Oh, that completely goes away, right? So I get 0 when I subtract because I'm going to change my sign and add. So I'm going to bring down the 3x. And I'm probably going to need the 6 as well because this 0 really isn't necessary for me to write here. So now I'm going to look for this. What times this? So I'm going to get a plus 3 as my last thing here. I multiply through and I get 3x minus 6. And so I get a remainder of 0. And so now, oops, okay. Now I can write this as, so f of x is equal to, the x plus 1 is the same. And now this is actually this times this. Okay? So I'm going to write in place of it x minus 2 times x squared plus 3. And now I'm as factored as I can do without being in the complex number system. We're not going to visit the complex number system, but it won't factor any further in the rational numbers. So I can find all of my zeros here, right? So I've already found that x equals negative 1 if I set this equal to 0, right? That's why when I find my zeros, this is what I do. And then I get x equals 2 from this one. Now I can try this one out, but as soon as I move it to the other side, I get x squared equals negative 3. So these are not real, right? Now, if we were in the complex number system, this would give us two imaginary solutions, but we're not. We're not going there. So this one does not give us any, but it is completely factored, as we can do it, okay? Because x squared pluses don't factor with a constant term, at least in the real number system. Okay, so let's look at a little bit more interesting one. So let's do this. So we have f of x is equal to 6x cubed plus 41x squared minus 9x minus 14. And so what we want to do first is we want to find the rational zeros. So I want to find all the zeros, and so we first want to list them all, the possibilities. Now this one's a little bit more interesting because the last ones, my numbers didn't have very many factors. So this time I don't have a leading coefficient of 1. So I'm remembering that from my rational zero test that all of my rational roots or my rational zeros will come from either factors of this, the constant terms, divided by factors of the leading coefficient. So all of my possible p's, so p, right, it's factors that will multiply together to give me 14. So that would be 1 and 14, and then 2 and 7. So those are all my possible p's. My q's, this time my leading coefficient is 6, so this time I have a few more to check. So I have 1 times 6 and 2 times 3 will also give me 6. Right, so my possibles, so this is what I choose a denominator and then I put it over, I put all of my numerators over that one. So all my possibles, so these are the numbers in the numerator and these are the ones in the denominator, okay? So first I'm just going to choose 1 to be in the denominator. So my possibles that come from 1 being the denominator are just 1 over 1, 14 over 1, 2 over 1, and 7 over 1. So I get positive and negative 1, 14, 2, and 7. Okay, so that's when I put 1 in the denominator. So this time I'm going to choose a different denominator. This time I want to choose 6. So this time I'm going to write all of my p's over 6. So that would be 1/6, 14/6, 2/6, and 7/6. Okay, now I'll simplify them and kind of cross out any ones that repeat because occasionally we get some that repeat that show up more than once. Okay, so the next denominator I'm just systematically going from left to right. I'm going to use is 2. So possibles are 1/2, 14 over 2, 2 over 2, and 7 over 3. Or 7 over 2, I should say. I'm not changing. So 1 over 2, 14 over 2, 2 over 2, and 7 over 2. All right, and then the last denominator I have here is 3, and so I'm going to write each one of these over 3. So I'll get 1 over 3, 14 over 3, 2 over 3, and 7 over 3. Now I don't want to check all these if they're repeating, right? Because these are all numbers that I can put into F to see which ones give me 0. Now obviously I'm going to start with the integers and hope for the best, but if these aren't successful, then I really kind of want to simplify things here. So this one here could also be 7 over 3, right? I'm just dividing the top and the bottom by 3, or by 2, I'm sorry. And that occurs right here. So this is a repeater, all right? So 2 over 6 could also be 1/3, right? That's the same thing. And so then I have this repeater. Means it's showing up twice. I don't need to check it more than once. All right, so then 7/6, do I have one? No, 1/2, that doesn't seem to repeat anywhere yet. 14 over 2 is actually 7, which I have up here, right? So this is actually, we'll just cross that one off because I've already got that one showing up here. 2 over 2 is 1, right? And that's showing up here, so we'll cross this one off. 7 over 2, I don't see that repeating anywhere. 14 over 3, no, and 2 over 3. And so these are my list of rational zeros. So these are my list of possibles. So this is a good exercise just to figure out what are my possibles. Now I hope that I'm not going to have to check every single one of these. I'm hoping that maybe one of these will have it, but it's a good practice. All right, so you can put this into your calculator and just double check, but My calculations tell me that f of negative 7 gives me 0. Okay? So let me just do that one more time. That means that, so if I go through this process, that means that x plus 7 is the factor. So I'm going to take x plus 7 and divide it into my original f. Now the good news is that once I get this down one more, because this is an x cubed, so when I divide one time I should have x squared. So then I don't need anything except for the quadratic formula or factoring. Alright, so I'm going to multiply this by something here that'll give me 6x cubed, so that's 6x squared. Multiplying through gives me 6x cubed. 6x squared times 7 gives me 42x squared. I'm going to subtract, so I change my signs and add. So this gives me negative x squared minus 9x. So now I want to multiply the x by something to give me negative x squared, so that would be negative x. Okay, I got negative x squared minus 7x when I multiply through. And I'm changing my signs and adding, so this gives me negative 2x minus 14. And so last thing, if I put minus 2 up here, I do get negative 2x minus 14. So I feel confident in my polynomial division. So my f now factors as 6x squared minus x minus 2 times x plus 7. And now I can just factor this or use the quadratic formula to find my last two. Or actually, if all of my zeros are rational, then I should be able to find them all this way. And in fact, these are rational. If I factor this, or whether I try out the rest of my list here, what I actually find is that f of 2/3 is also 0, and f of negative 1/2 is also 0. So if all of my factors, or all my zeros, are rational, then I can find them. They will be in this list, right? Negative 7 is right here, right? Because it's plus and minus, and then 2/3 is here on my list, and also a half is right here, right? And this is both the positive and negative. So all of these zeros were in this list. Now I could find them also, this will factor, and so then if it factors, then I should also find these. I'm not going to go through, you can practice factoring that, but I should get these as my zeros when I set them each equal to 0. But if all three of them are in fact 0, and I can find up to 3 of them because I have an x cubed polynomial, then I should be able to find them like this. Now in the previous example, right, we found out we could find 2 of them, but we're never going to find this factor, right, because it's quadratic and it's not really a 0. So this one is not a rational solution. In fact, it's a no solution in the real number system. But since, right, so if I had 4 rational factors, I'd be able to find them. They'd be part of my original list. Oh, it's not on that page, but so that is using the rational zero test. Now this will also factor, just in case you want to just double check, but this should factor as this. I'm not going to go through the procedure. You can figure that out yourself. So then there's my x equals 2/3, that's my x equals negative 1/2, and I get x equals negative 7. And so that's my using my rational zeros to find my zero test to find all the rational zeros of that.